Okay, so with square root of 2, we got 1 plus 1 over 2 plus 1 over 2 plus 1 over 2. For square root of 3, we got this. Okay.
1 plus 1 over 1 plus 1 over 2 plus 1 over 1. So we have this extra 1, and then we alternate 1, 2, 1, 2, 1, 2, 1, 2.
Okay. So pick another square root.
Okay, let's do the square root of 5. Let's see what we get. Now this time we get 1 plus 1 over 2 plus 1 over 4 plus 1 over 4 plus 1 over 4.
Oh, that's interesting.
So, yeah, this is the first one where we start with a 2, because square root of 5 is now above 2.
Yep.
And then it's 1 over 4 every time, which is kind of interesting.
Yeah, actually, one really interesting thing about this is it seems to be double. The square root of 2. Everything is double.
Yeah. It's interesting, the approximations have to go, you have to advance pretty far to get better and better approximations here, which is interesting.
Yeah, although, right. All right, pick another one.
Let's do maybe the square root of 51.
Okay.
Alright, so let's see, we start with 7. The nearest lower perfect square would be 49, so it makes sense. 7 plus 1 over 7 plus 1 over 14 plus 1 over 7, so we then alternate 7, 14, 7, 14, 7, 14. So far there seems to be a clear pattern in all of them that we've looked at.
Yeah. And this one actually, we saw, well, I guess here the denominator is 99, the third one.
Yep.
I guess we got 99 over 70, so we had 99 in the numerator. But even the third one here, which is 7.141414, is actually has it go up to 4 decimal places.
Yes. 4, yeah. You can see you don't get a better one until over 700.
Yeah, actually it's really interesting to compare that one to 50 over 7.
50 over 7 gets only to 2 decimal places. So
you would think, okay, well, 50 over 7 is a good approximation, so 5,000 over 700 is probably a pretty good approximation, but actually there's an even better one.
Yeah.
All right, do one more square root, and let's see if we always seem to see this repeating pattern.
Okay, let's see, we can go 129, maybe.
All right.
Just see if we get a pattern. Well, let's see, 11 plus 1 over 2, 2, 1, 3, 1, 6, 1, 3, 1, 2. So we're alternating 1s every time, but this next term isn't constant. We go from 2 to 3 to 6.
Yeah, so on that last continued fraction A10, change it to A30. So we're not sure if we're repeating here, but we can actually, we're only looking at 10, so maybe.
2, 1, 3, 1, 6, 1, 3, 1, 2, 22. That's interesting. 2, 1, 3, 1, 6, 1, 3, 1, 2, 22. 2, 1, 3, 1, 6, 1, 3, 1, 2, 22. So we've got a much longer repeated term. Stretching.
But it does seem to
here.
repeat.
Yeah, it does.
So it's an interesting question. So square roots do seem to exhibit this repeating behavior. So now we're going to move on to other kinds of numbers.